Assalamu alaikum everyone. Dear students, welcome once again to KPB School and College online class English version. This is Irene Parvin. Today I am going to discuss about the quantum theory of radiation and Bohr's atom model. Due to the limitations of Rutherford atom model, scientist Niels Bohr proposed his own model in 1913 concerning the structure of atom, and this model is known as Bohr's atom model. This model is based on the quantum theory of radiation. The quantum theory of radiation was developed by German scientist Max Planck, and uh, you have to know the quantum theory of radiation if you understood the Bohr's model properly. And according to this theory, any matter can absorb or emit certain amount of energy or its multiple, like a separate packet of energy is called quantum. I repeat it again. According to this theory, any matter can absorb or emit certain amount of energy or its integral multiple, like separate packets of energy, and this is called quantum. This quantum energy is directly proportional to the frequency of radiation, that is E proportional to nu. That means E equal to A is nu. Here E equal to quantum energy. A is equal to Planck's constant, and its value equal to 6.626 into 10 to the power inverse 37 kilojoule second, or 6.626 into 10 to the power inverse 27 joule 27 arc second. And nu is the frequency of radiation. And the radiation or emission of energy from a body takes place discontinuously in the unit of H nu, in the unit of H nu, or its integral multiple, or integral multiple. That is E equal to N is nu. Here N equal to 1, 2, 3, etc., which represents the energy level, and this equation is called Planck's equation. This is Planck's equation, and any emission or radiation of energy takes place discontinuously in the unit of h nu or its integral multiple, that is quantum energy equal to nh nu. I think all of you have understood the quantum theory of radiation. Now we will be moving our next topic, Bohr's atom model. Bohr's atom model has three main postulates. Number one, postulates of energy level, postulates of angular momentum, and postulates of radiation of energy. I would like to discuss at first postulates of energy level. Now I will be discussing about Bohr's atomic model, and number one postulates is postulates of energy level. You know electrons revolve around the nucleus in a certain circular orbit, and no energy is radiated or absorbed when electron is in stationary orbits, and these orbits are called energy level. Look at the figure, please. This is nucleus, and electrons revolves around the nucleus. And no energy can radiate or absorb when electrons is in stationary orbit, and these orbits are called energy level, and these energy levels are called first, second, third, etc. energy level according to the distance from the nucleus. This energy level is called first energy level, and this energy level is called second energy level, and so on. And the number which represents the energy level is called principal quantum number, and it is represents by n, and the value of n is 1, 2, 3, etc. Look at the figure, please. For first energy level, the value of n is 1, and for second energy level, the value of n equal to 2. And the first energy level has another name, which is ground state. And every energy level has certain quantum. This is very important, certain quantum. Every energy level has certain quantum. Okay. Now I would like to discuss about the second postulates of angular momentum. Postulates of angular momentum. Postulates of angular momentum. In a certain energy level, the electrons has angular momentum and it is fixed. I repeat it again. The angular momentum of electron in a certain energy level is fixed and it must be an integral of h by 2 pi. Integral of h by 2 pi h by 2 pi. That is angular momentum mvr equal to nh by 2 pi. This is angular momentum of electron and it is fixed for a certain energy level. Here m equal to mass of electron, v equal to velocity of electron, and r equal to radius of energy level. Radius of energy level. And you know electrons moves in a circular way. So Vr equal to circular velocity. And is, you know, is equal to Planck's constant. You have already know about this Planck's constant. And n equal to 1, 2, 3, etc. This is principal quantum number which represents energy level, and pi equal to constant. You definitely know the value of pi is 3.14. Okay. Now I would like to discuss about the third postulates of Bohr atom model, and this is postulates of radiation of energy. You know, when an electron is transferred from one energy level to another, it radiates energy or emit energy. I repeat it again. The third postulate of radiation of energy is when electron transferred from one energy level to another energy level, then it radiates or absorbs energy. If the electron jumps from higher energy, look at the figure please, higher energy level to lower energy level, then it radiates energy. On the other hand, if electrons jumps from lower energy level to higher energy level, then it absorbs energy. So this is radiated energy and this is absorbed energy. And you know this one is E1, the energy of this first cell is E1 and energy of second shell is indicated by E2. So I repeat it again, when electron jumps from higher energy level to lower energy level, then it's radiate energy. And when electrons jumps from lower energy level to higher energy level, then it absorbs energy. And this energy is the difference between the energies of two energy levels. This two energy is equal, and this energy, this absorbed or emitted energy equal to the difference of two energy between the energies of two energy level. This like that, and this is H nu. This is H nu, and here del E equal to difference of energy of two levels, and nu equal to radiation of energy. And A is, Planck's constant. And absorption of energy by electron from lower energy level to higher energy level gives absorption spectra, and radiation of energy or emission of energy by electron from higher energy level to lower energy level gives emission spectra. Bohr's atom model has many successes, and one is Rutherford's atomic model cannot mention the shape and size of energy level, but Bohr's model specifies the circular size of energy level. And secondly, Rutherford's model doesn't mention the changes of structure of atom when they absorb or emit energy, but Bohr's model states that the electrons moves from lower energy level to higher energy level when they absorb energy, and electrons moves from higher energy level to lower energy level when they emit energy. And thirdly, Rutherford doesn't explain the atomic spectra, but Bohr's explain the atomic spectra of hydrogen atom, which contain only one electron. Now I would like to discuss about the limitations of Bohr model. Though there are many success of Bohr models, but it has some limitations also. Number one, Bohr's model can explain the atomic spectra of hydrogen. But it cannot explain the spectrum of atoms having more electrons. Hydrogen has only one electron. I repeat it again. Bohr's model can explain the atomic spectra of hydrogen with one electron, but it cannot explain the atomic spectra of atoms which have many electrons. And the second limitation is when electron transfer from one energy level to another, there will be a single line in spectra. I repeat it again. when electron transform from one energy level to another, according to Bohr model, there will be a single line in spectrum. But after analyzed the spectrum with high resolving spectroscope, it is seen that there are several fine lines, and Bohr's model cannot explain about these several fine lines. And number 3, the Bohr's model specifies that orbits of electron in an atom is circular. However, later on it was proved that the size of orbit may be oval shape too. So, in previous class, we learned about the Rutherford's atom model, and today we have learned about the Bohr's atom model. Both of these models are very important for your upcoming exam. That's why you have to learn these two models properly. No more today. Thank you everybody. Take care.